Now, moving on to factoring. Before we were discussing how do you find the greatest common factor. Now we're going to actually use the greatest common factor. We're going to perform a function with it. We're going to factor with the greatest common factor out of a quantity. And what that means is, let's say we have the quantity 25. We'll use this same thing we had before, x squared y cubed plus 35 x to the fourth y squared. Well, we can't combine those, right? They're not like terms. But we can factor out the greatest common factor. And we already said on the last slide, the greatest common factor was 5x squared y squared. We're going to factor that out. It might help to remember that factoring is a form of division. We are dividing this out, but we're not throwing it away. We're going to divide it out and put it out here on the left-hand side. Okay? So we're going to divide it out of each term. So 25 divided by 5 leaves us with 5. X squared divided by x squared is 1, so we don't have to write the 1. Y cubed divided by y squared is going to leave us with a y. Notice with the variables, all we have to do is subtract. 2 minus 2 was 0, so we don't have to write it. 3 minus 2 was 1, so we just have to write it once. So if we look at the next term here, 35 divided by 5 is going to leave us with 7. X to the fourth divided by x squared, 4 minus 2, will leave us with x squared. And then y squared divided by y squared, the 2 minus 2 is 0. So that's it. We're done. We can actually put our parenthesis right there then and call it done. That is factoring out the greatest common factor. Once we determined what the greatest common factor was, 5x squared y squared, we factor it out. We pull it out to the left. Make sure it comes out to the left. It comes out to the left. Everything that remains goes in parentheses. Beyonce didn't mention that. Everything that remains goes in parentheses. So whatever's common comes out to the left. That's going to be the greatest common factor. Whatever's common comes out to the left, to the left, to the left. You got to make sure you say it that way. And then anything that remains goes in parentheses. Let's take a look at what happens with fractions. Let's say we had 1/2 x squared plus 1/8 x minus 1/4. Now we want to factor out the greatest common factor. And you might be looking at that and saying, well, the 2 is the greatest common factor for 2, 4, and 8. But with fractions, it's a little bit different. With fractions, we always want to go along the lines of what's the least common denominator. Least common denominator and greatest common factor in this situation are the same thing. We want to factor out the 1/8 because 2, 4, and 8 can all be 8. So we want to factor out the 1/8. And the reason that it all works out the same is this. Remember, when we factor out, we divide. So we're doing 1/2 divided by 1/8. And if you remember, when we divide by a fraction, we always multiply by the reciprocal. Well, here's why it works to use the least common denominator instead of the greatest common factor. We can always multiply by anything. So when we do the multiplication, the 2 and the 8 cancel, leaving us with 4/1. So we have 4x squared plus 1/8 divided by 1/8 is going to be 1/8 times 8/1. That's going to cancel, leaving us with 1. So that's just x. And now we have 1/4 divided by 1/8. That can't multiplies to be 8/1 and leaves us with 2. Notice what happens here. We no longer have any fractions in our polynomial. The fraction has totally been removed out over to here. Okay, so that's still a form of factoring, although it's really a multiplication process because you're factoring out a denominator. And when we factor out a denominator, we do the multiplied by the reciprocal, so it's actually multiplication. So when you want to factor out a fraction, factoring out the denominator, all you got to do is take each term times that denominator. So 1/2 of 8 was 4, 1/8 of 8 was 1, 1/4 of 8 was 2. All you got to do is multiply everything by the denominator. Put that fraction out there, and then multiply everything by the denominator. That's how we factor out the fractions. But when it comes to the factoring process, we take whatever's common, and what do you think we do with it? That's right. We take it out to the left, just like we did with numbers coming out of quantities. Okay? Quantities can also be a commonality that needs to come out. Consider for a second that you have x times x plus 2 minus 3 times x plus 2. You look at that and you can see, well, x plus 2 and x plus 2 are common. They're the same thing. So that's a common factor because it's x times x plus 2, negative 3 times x plus 2. They're both things being multiplied, therefore they are both factors, and they are common, so we can factor out the common quantity just as easily as factoring out a common number or a common fraction. And remember, when we factor out anything that's common, we take it out to the left, to the left. So that gives us x plus 2, and then whatever remains goes in parentheses, right? So when we divide out the x plus 2, we're left with an x. When we divide out the x plus 2, we're left with a negative 3. So the factorization becomes x plus 2 times x minus 3. And then the negative 1, what that means is if we had something along the lines of x times y minus 3 plus 2 times 3 minus y. Well, at first this looks like, well, that's kind of screwy. It's close, but not quite the same. The first thing I would suggest is this. Always, always, always work in descending order. Descending order would have us have the negative y plus 3 instead of the 3 minus y. And by putting it in this order, that leading negative, the negative in front of the first term of a quantity or a polynomial or what have you, is a clue. We never, ever, ever work with leading negatives. So what we want to do is we want to factor the negative out. The negative 1, we're going to factor that out. So we'll have x times y minus 3, and then plus 2, and I'm going to put parentheses here because when we factor that leading negative out, of course it's going to have to come out to the left. We're going to put it right there. And then when we factor the negative 1 out, remember it comes out of both terms. So the negative y divided by negative 1 is going to leave us with a positive y. But 3 divided by negative 1 is going to leave us with a negative 3. Okay, so we factor that negative 1 out, giving us x, y minus 3 minus 2 now, times y minus 3. And just like before, we have a common quantity here, so we can have y minus 3 times x minus 2. Okay, so don't let things like this throw you. Always put it in descending order first. Then when you see that leading negative right there, that will remind you to factor it out. Take that out. It's going to change the negative signs on your quantity, and then you'll hopefully come across something common that you can continue factoring. Alright, so that would be it. That is working with the greatest common factor. How do you identify it? You use the largest number, largest numeric factor of all the numbers and the variables with the smallest exponents. Or if there's fractions involved, you use the least common denominator. That's how you identify the greatest common factor. You always factor it out. And whatever remains will go in parentheses.